Hello everyone, welcome to my channel Learning Math with Shelly. In today's video, we are gonna work on a very important topic, and the topic name is upper bounds and lower bounds. Basically, it comes under the category of limits of accuracy. So this is the first part of this topic of upper bounds and lower bounds. And here we are going to learn about what is the meaning of bounds, what is the meaning of upper bound as well as lower bound, and how do we calculate it. Okay. So the topic is understanding the bounds. Now, bounds are used for the calculations to be more accurate. They tell us the lower limit and upper limit of a rounded number. For example, I say the length of this wooden piece is a particular wooden piece, it is 63 millimeters. If I say this statement 63 millimeters and I say to the nearest 1 millimeter, so that means this value is rounded off. What they are talking about here, the rounded number, that is this value, and this value is a rounded value, an approximate value, and it is rounded to the nearest 1 millimeter. So there can be actual value which is slightly different from this 63 millimeter. What is the lower limit for that value and what can be the maximum highest value that gives you the lower bounds and upper bounds. Next we have here, for example, you have a number 6.8 and we said this is rounded to the one decimal place. So its lower bound will be 6.75 and its upper bound is 6.85. This is because any number, if you take from 6.75 to the numbers up to one decimal place, if you round it up, it will be 6.8. And if you take any number which is just less than, here the word is less, if it is just less than 6.85, that will also be rounded to 6.8. Maybe you people have learned about like 6.8 is the value. Which numbers will round up to this one? One is 6.75 and the maximum will be 6.85. Now here one thing is very important. I will explain why it is 6.75 and how we get 6.85 here. But the most important thing is the lower limit, you can get it equal to condition also. But here it is always less than. Because if you see 6.85, if I take the exact value 6.85 and when you round it to the one decimal place it will become 6.9, and that is what I don't want. We want 6.8. So always remember, we will write here 6.85, but we will not include that value of 6.85. We will keep it less than 6.85. Whereas on the lower side we kept it 6.75 because 6.75 is the lowest value. If you round it to the one decimal place you will get it like 6.8. Anyways, we will be working on how to find out these values. But when we talk about the upper bounds and lower bounds, they are basically like the limits and they are written like this. This is also known as error interval. So we will be discussing all of these things in detail. Now, for example, if you have a kitchen unit which is 600 wide to the nearest 10 millimeters, so that means this is not the exact value. It can be different from this value, but under certain limitations. So here the actual value, it can lie from 595 millimeters to just less than 605 millimeters. So here if you see, it is written here the width is between 595 and 605 millimeters. This side it is only less than sign and here is less than equal to. So this is also known as error interval. That means which values are acceptable, how much error is acceptable in for this value 600 millimeters. If it is, you have to find it to the nearest 10 millimeter. So that will be from 595 millimeter to 605 millimeters. If you change this 10 millimeter to some other value, definitely this error interval will also change and we will be learning about it as well. Next is, what are the different types of bounds? As I have given examples and I show there is a lower value, less than equal to the rounded the another value. So this is known as the lower bound. That is the lowest possible value. This is lower bound and this is the upper bound. Upper bound and lower bound, basically these are the simple concepts and you can understand it in a very simple language. So here it is written, lower bound is the smallest value that will round up to the estimated value. So we had like 595. This is the lowest value. It can be rounded to 600 if we take it up to the 10 millimeter, that grace time. Okay. Then we have upper bound. Upper bound, see, most of the students, they get confused why it is written here smallest value. This is not by mistake. Upper bound is the smallest value that will round up to the next estimated value. See, here this value is 605. Okay, though 600, we cannot take this value exact 605, but this is still called upper bound, because if we take this value, this is the smallest value which will round to 601. Okay, so 605 if we take, so then you will be getting the next value 610, sorry. Okay, if I take a number 610, its limits will be 605 and 615. So again here, if you see 605, it serves as the smallest value for the next rounded number if you take it to the 10 millimeter. The nearest accuracy is 10 millimeter. Is this point clear? So upper bound is the smallest value that will round up to the next estimated value. So that is here 605. I cannot take it for 600. Any value just less than 605, that will be rounded to 600. But if I take a value 605 or even more, it will round to 610. Why did I choose 610 after 600? Because we are taking it 10 millimeter to the nearest 10 millimeters. Now we will be working on some of the examples as well. So here we have the question, how to find the lower bounds and upper bounds. There is a very straightforward method to find out the lower bounds and upper bounds. You will see in every question you will be given a degree of accuracy, like nearest 10 millimeters, or you will be given like to the nearest centimeter. So these are the accuracy, limits of accuracy. What you need to do, you just need to half that accuracy. You need to add that accuracy, that value, half value to the rounded value or the given value, and you have to subtract it as well to get the lower bound. Let's apply these rules to perform some calculations here. So we have the question, work out the upper bound and lower bound of the following measurements. We have 32 centimeter. This is my estimated value. I have to measure it to the nearest centimeter. That is my limits of accuracy. So nearest centimeter means nearest 1 centimeter. So I will half this value of 1. So it will be 0.5 centimeters. Now you need to add this 0.25 centimeter to 32, and you have to subtract also. When you will subtract, definitely you will be getting smaller value, that will be the lower bound, and also you will be getting upper value when you will be adding it. So this is 31.5 less than equal to 32 less than 32.5. So this is the upper bound and this one is the lower bound. Again, for lower bound, you will use less than or equal to, but for upper bound, only less than symbol will be included. Then we have the next question. 140 centimeter to the nearest 10 centimeter. So here the limit of accuracy is 10 centimeter. I will do half of it, which is equal to 5 centimeter here. So I will add and I will subtract 5. So 140 5 less than that, it is 135, less than equal to 140 and less than 140 plus 5, which is 145. So this is our error interval. the value of the object can be taken from 135 to just less than 145, this will be acceptable. 135 to 145, and every value within this range will be acceptable. Now let's try the next set of questions. 8.4 centimeters. See, accuracy can be given to the decimal places also. 8.4 centimeter measure to the nearest one decimal place, or you can say nearest 0.1. So that is the one decimal place, 0.1. So again, I will do half of this, 0.1 divided by 2, which is 0.05. And then we have 8.4 centimeter. So the lower bound will be 8.4 minus 0.05, and upper bound will be 8.4 plus 0.05. So this will be 8.45 less than 8.4 less than equal to 88.35. Okay, then you can get it for two decimal places also, like here it is written 0.01 second. So that means answer will be accurate up to two decimal places. If you see here also, the answer is given up to two decimal places. So in that case, if they have not given you this thing and this is, so you keep ones place 0, tens place 0, and second decimal place that you can keep is 1, and then we have to divide it by 2, so it is 0.005. So one value, the lower value will be obtained by making it 15.89 minus 0.005, and the upper value you will be getting as 15 point, sorry, this is 15.89 plus 0.005. So this way you can calculate this result and you can find out the result. So this is a way to find out the lower bounds and upper bounds. Now we have lower bounds and upper bounds for two significant figures or for three significant figures, like that also. For example, this question here, this is 230 millimeters. This is something most of the students are confused. We have to give the accurate answer up to two significant figures. If it is two significant figures, that means it is like 10. So here we have two significant figures. So 10 again you have to divide by 2. So it will be 5. And then you have to make 230. And here 5 less than 230, which is 225. And here 5 more than 230, which is 235. So this way you can solve the questions of significant figures also. This is for two significant figures. You can get it for three significant figures. Then you will take 100 and so on. For two significant figures, 10. For one significant figure, 1. For three significant figures, 100. So third significant means third one should be a non-zero value, and that we will take as 1. Now this limits of accuracy we can apply to the different word problems also. Like there will be the word problems in terms of you have to find the area of a triangle, and you have to find the upper bound of that triangle, you have to find the lower bound of the area of that triangle. So we will be working on these operations. Like if I'm adding two quantities and I need to find their upper bound of the resulting added quantity, or if I'm subtracting two quantities, if I am multiplying two quantities, or if I'm dividing, then how to find out the upper bound, how to find out the lower bound, that will be explained in the next lesson. So this was all for our today's lesson. Here we covered about the what is the error interval, limits of accuracy, how to find the lower bound and upper bounds in decimal, if the decimal nearest decimal place is given, if the significant figures are given, or even if the simple numbers are given. Thank you.